To tell you who IMC is, we're a specialized management company founded back in '89, and we basically put our folks into situations where we help tech companies and resource companies solve problems, so accelerate growth and remove roadblocks. So it's sort of a find, fix, fund model. We help companies find new customers, new markets, sales support. So that could be like an outsourced chief marketing officer if you can't afford a full-time person. And we also tend to go in, rather, it's not just sales, it's more going in at the executive level and doing strategic pitches on how technology or something like that will have a big impact on your bottom line. The fixed side is optimize operations, do M&A, succession planning, divestitures, and the fun part is providing growth capital for expansion. A typical IMC guy, we got about 75 people. It's an engineer who got their hands dirty in the field doing something or turning some valves and got to senior management level. We also have some government ministers, former deputy premier, so we're pretty well tied into the provincial government too. So, getting down to business. My background was, got my hands dirty in plant startups, geophysics, data acquisition stuff, and later in manufacturing. At one time I was CFO of an industrial gas company, so pulled out a scenario of an industry I know a little bit about. So really, air separation is about producing liquid oxygen, nitrogen, and argon. Large compressors, turbo expanders, and these facilities have usually a loading and distribution division. We got tractors and cryogenic trailers, and that's a critical service. So you're supplying hospitals and refineries, hospitals with oxygen and nitrogen refineries and mines and stuff. So you really can't stop delivering these things. It has to be continuous. So our job, is there a business case for magnetic filtration in an operation like this? So this is a typical air separation plant. That a lot of the compression's in here. That tall tower there is called a cold box, gets to minus 200 degrees C. And so really what we're doing is sucking in fresh air, some initial filtration. This is the main air compressor, about 3,600 horsepower, and then goes through some molecular sieves to get out water and hydrocarbons and CO2. And then the expanders basically take the compressed air, expand it, cool it. More big compression if you want to sell it in a gaseous form, say you're selling it to a refinery, nitrogen pipeline, or selling gaseous oxygen, another big compressor to get it out to the customer. Could be, a few miles away. And if you want to condense out the liquids, then again, more compression, and we condense that out. We're going to look at, there's a whole bunch of potential savings in economically with additional filtration. So we're going to look specifically at major rotating equipment lubrication in terms of the preventative maintenance schedule improvement, and also with extended overhaul. Failure avoidance, it's, need a lot of data to get that, and we don't have a lot of data yet. Rotating equipment cooling, obviously potential. Process air intake, again, you're sucking in massive quantities of air and having to clean that up. So there's also some big potential savings there. Product filtration, so the liquid product to the customer outside the back end of the truck, potentially opportunities there. So on the other, we're just going to look at the tractor lubrication side of the transportation. So just 4 elements. So in terms of technology selection, for magnetic filtration, we would go with the compressors and expanders. The 1i Industries, on the Lube Oil side for 1i Industries, magnetic scrubbers. We'd probably use a dual inline scrubber rather than the single shown here. And for the tractor units, Advantage 9000, again, put the whole kit on, but we're just going to look at the economics of the actual Lube Oil. So this particular plant has two two separate process trains. For simplification, they're similar to this. Again, we're cooling here, or cleaning it up here. There's massive opportunities also, which I didn't talk about, as for the glycol systems here, because in this particular plant we had a glycol tube failure, and it was expensive. So again, here's the cold box I talked about. So the gaseous nitrogen comes off. So at minus 196, the nitrogen separates out. You can get the liquids. Minus 186, the argon comes off, and 183, the oxygen comes off, and then we load it onto the trucks. So a typical oil change interval on the big compression and the turbo expanders is 12 months, and these things have 100-gallon oil reservoirs, so they're pretty big. So with 400 liters. So let's get into the numbers. I got lots of numbers, and there's only about 15 of these slides. So in this case, we got 6 different units. The main air compressor for train 1, recycle train 2. There's a whole bunch of other little pumps and compressors, but for simplicity, let's just stay with a few of the big pieces and see what the economics look like. So again, train 1, train 2. Each oil change costs $10,000 for the bigger units, $7,000 for the expanders, oil and filter change. And the philosophy here is, instead of doing this every year, we're going to now do it every 2 years. So every second year, we're going to have some savings. So really all we're doing on all these tables is going to be how much savings are we generating. So we got $30,000 for the initial equipment purchase and installation on the 6 units. And so every second year, we're going to be getting this $54,000 benefit. Overhauling these things is not cheap. $225,000 for the main air compressor, $250 for the recycles, $110 for the expanders. So you're looking at $1.1 million every time you're doing an overhaul. And the current interval is 5 years on these things. So what we're saying here basically is we're going to try to take this out to a 10-year interval. And this is fairly clean service. We're not talking dirt in mines and stuff like that. So based on what we've learned so far from the cases, we think it's fairly reasonable to pull this off. Partial EBITDA earned due to scheduled overhaul. So basically, if you're doing this is the lost profit due to downtime, which you're actually not foregoing. Again, as I said, you can't stop delivering to customers. So really all you're doing is buying product from your partners or your competitors that may be 500 miles away, but still shipping that same oxygen to the same hospital. So you're losing some margin. So if we look at the net cash flow, our initial investment of $30,000, and then our savings as they flow in, we'll just tabulate it all up so it's easier. So we're looking at net present value at 6% discount rate of $1.2 million over 10 years, and a modified internal rate of return with the financing rate of 10% and a reinvestment rate of 15% of 62%. So it's pretty nice rate of return. There's a picture of the inside of one of the process trains, and here's a picture of the main air compressor. So in the payback on this, basically, we're not doing our oil change till the end of or not foregoing our oil change till the end of the first year. So basically, you're going to have a payback of 1 year on this thing. On the transportation side, so this is like, I call it an owner-operator situation, but there's 17 units. So we ran these units as long as we could and would overhaul them. So if you look at the before-after situation here, typically, what's currently happening, oil filter changes, so you get about a total of about $400 per oil change. Lost margin, so again, what profit do we lose by turning these things around? We said 0 because it's not 100% utilization, so we can always squeeze in an oil change. It's not a big deal. But right now, doing 25 oil changes a year, and so about $9,800 a year on that, so annual fleet cost $166,000. After putting the magnetic filtration in, obviously filter cost goes away, but be very comfortable going down to eight oil changes a year. These are very high mileage units. And so you're basically going down to 45,000, so your net savings is $120,000 a year. That's a liquid oxygen trailer. So these are like, I don't know, 300 to 500 grand, depending on what shape you get them in. And here's where there's the cryogenic pumps here where we pump the liquid oxygen into the hospital tanks, for example. And again, you might be able to stick some kind of magnetic filtration on there. So overall, the cost savings here, again, in this case, the payback is pretty much first year, no problem. Again, we see the cash flows over time. Now, I should touch on the overhaul frequency here, based on the existing and some of the new units coming into the fleet. About $30,000 per unit to overhaul, and we'd be basically going from 3-year to 6-year overhaul interval. So in year 3, we'd be saving $250,000 on part of the fleet. Year 5, $270,000 on the other part of the fleet, and then the same fleet again in year 9. We'd be skipping that particular overhaul. So summarizing this, net present value of $1.2 million and rate of return of 50%. So again, if I'm a CFO and I'm saying, okay, where can I spend my money in the next 12 months, 24 months? There's not a lot of competing investments that are going to be at 50%. And when you look at it, it's a rounding error. The capital investment is a rounding error for most companies. So we just look at the big picture here. That's what liquid oxygen looks like. We see initial investment of $100,000, basically giving us $2.5 million return, 54% when you combine the operations and transportation. So you got to pitch it at the right level in the company, right? And so if you can come up with this kind of argument and go through the layers of management so that your manager looks like a hero, then Rich and I were talking about this. Yeah, you just basically got to convince the people all the way up the chain. So in addition to the pure economics, again, when you're dealing with, at the executive level, you're going to have a whole bunch of other hot buttons. Safety, obviously. In this case, we're going to reduce our hazard exposure by 68% due to less preventative maintenance, labor hours and transportation. Safety, 50% reduced hazard exposure due to less preventative maintenance and labor hours and operations. Environmental, same kind of numbers, basically reducing the oil and filter consumption in both types of the operation. And critical equipment failures, again, hard to measure, but we had one, and boy, it was painful.
You're talking about moving your oil changes out, and that moves your overhauls out. The cost of your overhauls, have they gone up since you moved them out?
Well, again, this is a proposal. This hasn't been done yet, right? So, yeah. But, and again, we're looking at, you could probably add, oil pumps and all the other stuff onto it. But, so your investment wouldn't go up, but your points of failure would go down for sure. So, for the overall turnarounds, I think if you want to extend your turnaround interval, you got to have more of the equipment on there. You couldn't just do the big guys, right?
Your compressors are running 24/7 then, 365 days a year?
Yep.
Train 1 and 2?
Sorry?
Train 1 and 2?
Train 1 and 2 running continuously.